Hello and welcome back. In this lecture I want to talk about creating a string, specifically how you can do it in C using a character array. I tend to use the terms string and character strings interchangeably, but really a character string is the char array that we're going to talk about. It's a very important concept. We're going to be able to now utilize words and text in our program to do all sorts of things. Now, C itself doesn't have any data type that represents a string. There's nothing there. Many languages support either an object or a data type of type string. Now, because there is no data type C in string, you can't use any of the operators on the string. So what we'll end up doing is we're going to end up using this standard library, and there's all sorts of string functions that we're going to talk about. We have 3 lectures dedicated to the various string functions that you can employ. And this will help us manipulate the strings, get information about the strings. But you cannot utilize operators on strings. No plussing or minusing strings. Nothing like that. Strings in C are stored in an array of type char. We know what an array is. We know what a char is. A type char is a single character. An array, you can just store multiple elements in the same name. So it makes sense that a string would be inside of a character array because a string is many, many characters. So characters of a string are stored in adjacent memory cells, 1 character per cell. You can access it just like you access an array as well. But how you would actually declare a string in C is you would simply use the char type and then the brackets to indicate the size, just like a normal array if you were to create it of a different type. Char, and then whatever your name is, and then the size of the character array inside square brackets. That's how you can declare a string in C. Now, when you do declare the string in C like this, there's no actual data associated with it. You're just specifying the size. That's the simplest way. So the variable can accommodate a string that contains up to 19 characters. Remember this null character. If you say that your string size is going to be 20, that means only 19 characters can actually be stored because you have to have that 1 extra character for the null. Keep that in mind. Declaring a character array as 20 means 19 characters can be stored there. When you specify the dimension of an array that you intend to use before a string to store a string, it must be at least 1 greater than the number of characters in the string that you want to store. The compiler will automatically add the null terminator at the end of every string constant. So what you should really do is when you create these character strings, you should be initializing them. Okay? So you can initialize a string variable just like you can initialize an array. You put each character inside of these brackets. Right? So this looks very similar to if you were to initialize elements in an integer array. But if you say char word and then inside the squiggly brackets, you put in each single character, that would create a character array. So it's the same as any other array initialization. In the absence of putting the size, the C compiler automatically computes the number of elements in the array and then adds 1 for the null terminator. So it's based on the number of initializers you have in between the brackets, curly braces. This statement is going to reserve space in memory for exactly 7 characters. HELLO, exclamation point, and then the null terminator. And this little diagram on the right shows you that. Automatically adding that null terminator. Now, it'd be really kind of a pain in the butt if you always had to initialize your character arrays with single quotes followed by commas. So what you can do is even shorthand notation is you can just put double quotes around that. So you can either specify the string explicitly, like in that first example, and then you would have to actually use a string function to apply data to it, or you can let the compiler do it for you. The problem with doing it explicitly is you always have to remember to add that extra character for the null. So what you should really do is you should be letting the compiler figure it out for you. So don't put any numbers inside those brackets for the size. Because if the size specified is too small, the compiler cannot fit the terminating null character at the end of the array. And it doesn't put one there. And it's not going to tell you that it didn't put one there. So you're going to have a bug in your program and you're not even going to know it. Best practice is when you're using a string literal and you're initializing a string to just let the compiler figure out the size for you. Do something like make it a larger size or something and then just put it in there and it will figure out the size for you. So do not specify the size. Let the compiler figure it out. This way you can be sure that it's going to be correct. Just leave those brackets as empty brackets and assign it with the assignment operator, and then inside double quotes you can just put it. You don't even need the square brackets. This is the best practice. We'll go through an example. You can also initialize just part of an array of elements of type char with a string. So if you actually created a size that was really large and you only assigned a couple characters, that's fine as well too. You're only initializing some of the characters. All the other characters are just going to be empty. So what will happen here is the compiler will initialize the first 5 elements. Stir 0 to stir 4, all of those characters are string constant, and then string sub 5 will contain the null character. Space is still going to be allocated for all 40 elements in the array, but only 5 of those are going to be used. 4 plus the null character. So again, your best practice, don't actually specify a number inside the size. Just assign it a string literal with using double quotes. That's what you're going to end up seeing. Now, if you didn't initialize and you just created the character array with a size, how do you put data in it? Well, because it's array, you can't just assign data. Right? We know that if we had an integer array, we can't just assign an integer array the number 5. It doesn't make sense. You have to specify the actual elements. You have to specify the indices. So you can't do something like declare a character array with 100 characters and then say s equals hello. That is not going to work. Because again, s is an array. Even though it's a string inside double quotes, it's still an array in memory. So if you're performing an assignment operation, you cannot assign one array of characters to another array of characters like the above. If you want to assign data to a character array after you've declared it and after you've initialized it, you have to use a special function called stir copy. And we're going to talk about that in another lecture. So up until this point, when you create your strings, they're going to be string literals. They're going to be inside double quotes, and you're never going to modify them. So this is perfectly valid as well. You could actually just access each character or each element in the array by the index and specify each character. So s sub 0, s sub 1, and then put a single character in a single quotes. You could assign it that way, but imagine if you had a string that was 100 bytes. This is going to take a lot of lines of code. So you don't want to do that. What you're going to want to do is initialize it when you declare it with no size, and then specify, if you ever want to modify it, use stir copy. As far as displaying a string as output, we're still going to use that printf function. When you want to refer to a string anywhere in your program, you just use the array name by itself. You don't have to specify indices, because indices inside the array is going to specify a single character. If you want the entire string, you just use the array name. So if you're using the printf function to display output, you would just do the following. Inside the double quotes, you would use a %s as your format specifier, and then just the name of the character array. So you don't treat it like other arrays when you want to access it. When you want to access it, just the name, no actual indices or brackets. And the %s format specifier is for outputting a null terminated string. Remember before we used %d for integers. We've used, you can use %c for characters. For strings, you use %s. And those are character arrays. And the null terminated, it expects a null terminated string. So however you initialize the string, if you did it with no size and null terminator was automatically added, or if you created it with a specific size and you added it, or if you added it explicitly, it doesn't matter. It just has to be null terminated. The printf function assumes when it encounters the %s format specifier that the corresponding argument is a character string that is terminated by a null character. That's what it expects, so it has to be that way. To input a string, we know how to input other sets of data via the keyboard using scanf. We're going to do the same thing for inputting strings. We're going to use a scanf function. With the scanf function, it's going to be the same way, except you're going to use a different format specifier. So for strings, you're going to use a %s as input, and that's used for inputting a string. The other thing to notice here is there's no ampersand for the variable name because it's a character. Remember we mentioned you only have to provide the ampersand, the address of operator, on strings. The reason being is when we talk about pointers, it will be more clear, but char input, even though it's a character array, it's a pointer. And scanf, as its second argument, takes a pointer. And so that's why you don't have to do it. When you declare integers and doubles, those are not pointers. And so if you want to read input from the keyboard using scanf, the second argument expects a pointer, you have to pass in an address. Now with the scanf, when you do a string, scanf is only going to read up until space. So if you do scanf and you type in Jason is a instructor, the only thing that's going to be stored in input is Jason, because once it hits that space, it's not going to read the rest of the string. So there's other functions that you can use to read the entire string. Some of the examples we're going to use will probably do that. You can do things like fgetS, which is another way to read input from the keyboard, and that will read the entire string regardless of spaces. But there's another one, I think it's called get_s for C11. But we'll talk about that more, but that's just one thing to remember when you're reading input for strings. It's only going to read all the way up until the space. How about testing if two strings are equal? Well, up until this point, we have tested all variables to see if they're equal. We just use equals equals, right? But with strings, this is not going to work. The equality operator, remember we said that strings are character arrays, so you can't use operators on them. And the equality operator can only be applied to ints and doubles, or floats, or characters. It does not work on structures or arrays. You can't compare two arrays. So it's not going to work with strings. If you want to determine if two strings are equal, you have to explicitly compare the two character strings character by character. So you'd have to look at each element in the array index by index. However, that's really a big problem because that would be really tedious. So we're going to talk about how you can do it very easily using a stir compare function from the standard library. But you cannot use the equals equals. Remember that. And again, just as a reminder, I've said it a couple times, I want to say it again. The string constant x inside double quotes is not the same as the character constant x inside single quotes. X inside single quotes is a basic type. It's just char or char. X inside double quotes is a derived type. It's an array of type char. X inside double quotes really consists of two characters, the x and the null terminator, the null character. So keep that in mind. Here is an example of how we can create strings, either declaring them with a size or initializing them on the same line. Now this is best practice. If you're going to use string literals, what I would do is I would do what it says right here. Create the character array, do not specify a size, and then to the right of the assignment operator, have double quotes. The compiler will automatically create the right string and add a null terminator to it. If you specify a size and then you don't have enough characters, it's not going to store it. All right, so just create character string literals by using the char data type, the name of the variable, and then empty brackets. This program, let's see, this program is going to, I think, count the characters in an array. So it's essentially going to get the length of the string. What we're doing here is we're creating a variable named count in two character arrays with two different strings, to be or not to be, and then comma, that is the question. Char stir1 is going to have a null terminator after b, and stir2 is going to have a null terminator after question. So we have a loop here that's going to go through the first array from count equals 0 all the way until we see a null terminator. And we can use the not equals in this case because we're comparing a character, right? Null terminator is a character. It's perfectly fine to compare characters. So our while loop is going to go all the way until we see a null terminator. Once we see a null terminator, we're going to jump out. Count is going to be equal to the number of characters in that string. So it's the length of that string. We do it for both strings, and you're going to notice that basically both strings will have the correct length because we're just going through each one. To be or not to be is going to be something like 18 characters. Had to quickly count them. Sorry about that. Now, you're never going to really need to do anything like this because we have a nice helper function with stir length to find lengths of strings. But again, what this is demonstrating is that the fact that it is an array, and if you want to compare or find the length of a string, you can use the not equals and look at the character, the null terminator. I hope this was helpful. This is how we're going to define and initialize string literals. Thank you.